Something else that's fun to look at is manipulating, like doing symbolic manipulation. I don't know how to spell, symbols and stuff. Okay, so manipulating symbols is super fun. So say I have some equation, and it's, I think we had these already. I don't know, x plus, wait, let's do this one. I like this one. First of all, CLC clear, because I want to be safe. Sims, x and y. Let's do y is equal to 2 times x plus 3 squared divided by x squared plus 6x plus 9, right? 6 times x plus 9. And you're like, woohoo, I got something amazing. But like some like super secret part of you should be like, wait a second, because what this looks like is 2 and then x plus 3 squared, and then on the bottom, like there's like a line, and then on the bottom it looks like x squared plus 6x plus 9, and you're like, but I know that that means that, let me put stuff here on the top, that's still 2 times x plus 3 squared, but on the bottom, that's whatever you call it, thingy, that I can factor that. And if I factor that, I get x plus 3 quantity squared. And if I do that, then the 3's cancel out thingies and I get 2. All right? So you should be excited, but MATLAB doesn't seem to understand that. So what I can do is I can actually say simplify. And it goes 2. You're like, yay, I knew that. That's incredible. Woot. Now, if we do this in terms of an equation, I don't know if we get, it's always fun to see what things do whenever they're equations versus when they're expressions. So I'm going to call this my funny equation, and it equals y is equal to that. And now I want to simplify my funny equation. True. That's weird. Oh, that's because y was already defined, so I need to do this again. So that's why we're constantly doing this. There we go. Ooh. Oh, that's beautiful. I like it. I was not expecting that. Okay, this is amazing. I don't know if you see what just happened. Okay, so whenever I use a little equation thingy, it's like, oh, I can simplify that. It simplifies to 2. But remember like the thing from algebra where like I can't actually divide by 0? So even though these cancel out, it's really important because whenever you cancel those out in algebra, you're supposed to like make a little note off to the side that the domain does not include x equals -3, because if I put in x equals -3, then I get a 0 on the bottom. You're like, but they cancel out. I'm like, but you have to go with the original equation. You're like, ah! Okay, so anyway, I'm really excited about this. Whenever I asked it to simplify my funny equation, look what it said. It said, well, here's how it simplifies, because so this is my equation, and then whenever I ask it to simplify, it says x cannot equal to -3 because it can't. So whenever I did it over here, it just like went 2. Like this is like, so this up here is like first semester algebra student, and this is like awesome sauce algebra student who's like, the answer's 2, but I just want to let you know that x can't be equal to 3. So this is like the kid who's like really excited about algebra, and this is the kid who just like wants to move on with life. But this is like, oh my gosh, this is amazing. Okay, so anyway, you can simplify the funny equation, and it actually tells you what x cannot be equal to, and this is why we love MATLAB, because it makes us happy. Okay, so earlier we had something where we said like, well, so we had symbols y1, y2, and x, and we said that y1 was equal to x plus 1 quantity squared, and y2 was equal to x squared plus 2x plus 1. And we tried to say, okay, well, if, I'm just retyping this, if y1 is equal to y2, then we say, woo, yay, and can't spell, and otherwise we say, oh noes. And we ran this and said, oh noes, but that's stupid because we know they're the same thing, but it doesn't care. It's like, no, whatever. Okay, so we can actually do something with this now. Instead of comparing 2 different equations, we can compare the 2 simplified equations. And if we compare the 2 simplified equations, then it comes back with that. So it says, oh, I see it now, they're equal. Remember we tried to add 1 and y1 and y2, and it was like crazy. crazy numbers. And you're like, but shouldn't it be simpler? And the answer is yes. I can simplify y1 plus y2 and I get 2 times x plus 1 quantity squared, which is pretty amazing. It's really hard not to get too excited. Wait, yes, it's hard not to get very, very excited because it's easy to get excited. So there. That's what we did. Okay, so here's some good things to practice with. So I'm going to do this. I'm just going to copy and paste this because I like it. Okay, so here's some additional functions that you want to practice with. Whenever you try them, be sure that you try them on both symbolic expressions and on equations because you're going to get very different, sometimes kind of different. Like this was like hardcore, awesome different, right? So you just never know. The best way to do it is just to practice it. You want to practice with paper and pencil sometimes just to get an idea, so you can play around with it a little bit, because sometimes, you know, algebra, depending on your state of mind, isn't very mental. It's very, like, if I have a pencil in my hand, I can do algebra kind of thing. So this is really something you want to practice with. So remember, learning is like something you have to do on purpose. So pause the computer, try all these things out, try them on expressions and equations, and I'll see you in a sec. All right, so we pretend that happened. Alrighty, so what do each one of these functions do? All right, so let's try just expand. And for all of these, I'm probably going to have to do a little CLC clear. So this is going to be for expand. Start with CLC clear, sims, I don't know what I'm doing. So expand, what is it going to do? I don't know, we'll find out. Okay, so we'll say y is equal to x plus 3 quantity squared. And I'm going to expand y and see what I get. Okay, that's kind of what I expected. I expected expand to like multiply something out, so that's not a problem. Let's do it again on a, I don't know why I did x, y, and z. So let's say I have an equation which is y is equal to x plus 3 quantity squared, and I want to expand the equation. Why are you yelling at me? Oh, you're not. Okay. Okay. Kind of did the same thing. Let me try it. So just to be kind of fun, I know. There. Okay, so it expanded both sides of the equation. So that's kind of cool, because if I tried to do that up here, it'd be like, I don't think so. So that's another kind of a feature, I guess, of the, whatever you call it, equation versus expression, is that the left side doesn't have to be perfect. It can be all kinds of weird. So there, it expanded both sides. Basically means it multiplied it out. All right, factor. I can probably, again, guess what that's going to do. So let's try factor. CLC clear. So s, y, and s, x, y, and z. I don't know why I keep doing x, y, and z. It just makes me happy. So I'm going to think of something I'm going to have to factor out. So let's go y equals x cubed plus 3x squared plus 3x plus 1. And I'm going to say I want you to factor y. And it's going to be like, awesome! Yay, I knew that was going to happen. Because I'm kind of awesome at algebra, just not at, adding and subtracting. CLC clear, so let's do this as an equation. I don't really need x, y, and z, I just keep doing it. So my equation is x equals that, and I'm going to factor my equation, and it just does that. So again, on the left, I could actually say x squared minus 1. And then we go x plus 1, x minus 1 on the left, and then factor it out on the right. So that's kind of neat. And again, I wouldn't be able to say x squared minus 1 on the left up here, because it's like, you can't do that with equations. But I can do it symbolically here. So that's neat. All right, what am I going to do next? Numden. Numden. Numden sounds funny. Help, numden. Numden. Ooh. Numerator and denominator. It's kind of a boring name for a function. Numden. All right. So, numden. It's like a terrible name for a child. This is my little one, numden. All right. So anyway, numden. I'm gonna stop now. Okay. So let's say sims x and y. Y is equal to, we'll go x plus 3 divided by x plus 6, and I go numden. Okay, I had to say it that time. Why? And it just says x plus 3, and you're like, that's stupid. It said it was going to give me both, so help. I'm going to not say it. Look, so if you look at the usage, I actually have to do both. Now this might kind of be something you remember, like if you remember doing mesh grid, is if you didn't ask for 2 outputs, you didn't get 2 outputs, you only got the first one. And MATLAB always does that on purpose. By default, if you don't ask for any outputs, it only gives you the first one. So I could say this is the high one, and this is the low one. Loon is numden. So the high one is the x plus 3, the minus 1 is x plus 6. Kind of neat. Let's see what this does with an equation. My equation, y equals that. Can I numden my equation? No. It says I have a moped mex error. I don't even know what that means. Basically, it's telling me no. And that kind of makes sense, because how do you have a numerator and a denominator of an equation? That's just a little strange. So can't do this one. All right, I'm cool with that. I'm strangely comfortable with it. All right, now I'm going to collect. All right, so what do I do with collect? Okay, help collect. Has 2 inputs, regards each element of the symbolic matrix S as a polynomial in terms of V, and rewrites it in terms of powers of V. Okay, that makes sense. Maybe it makes sense. So I'm going to CLC clear it. Sims would be y and x and z. Now I want them all. All right, so let's do something in terms of x, y, and z and see what happens. So let's do x plus 3 squared plus x plus z squared. I don't know what this is doing. I'm just trying. I'm going to do collect y, but collected by x's. All right, I'm going to see what this does. Okay, so let's see what we get and see if it makes sense. So if I multiply this out, I would get x squared plus 6x plus 9 plus x squared plus 2xz plus z squared. So basically I said, I want you to collect y, the equation y, and I want you to collect the x terms. I'm like, okay. So basically I'm going to get 2x squared, and then what else has an x? So basically I'm going to say, I'm going to factor the x out of here and here. So if I factor the x out, I should get 6 plus 2z, and then I get z squared plus 9 left over, and that's exactly what I got. And just in a different order, it's 2z plus 6. So basically I'm going to collect everything with terms of coefficients of x. So try this one. Try to do, so that's this one. All right, so then let's see. If you didn't get anything on this initially, now try it. Like pause the video, see how far you can get, and see if you can anticipate what this output's going to be. Okay, so I'm going to collect x. If I'm going to collect the terms in terms of z, if I look at the original, the only things that have z is it starts off as z squared, then I have a 2x times z, and then everything else is a non-z term. So basically I have a 1 in front of the z squared coefficient, a 2x in front of the z coefficient, and a 2x squared, come on, plus 6x plus 9 term in front of the, so this really is times the z to the 0, right? So this is z to the first. So I collect the z squared terms, the z to the first terms, and the z to the 0 terms. And they might be in a different order, and they were simplified a little bit, but they're still there. It's actually interesting to see how that was simplified. So if I don't like the way that looks, I wonder if I could expand the collection. Yeah, there we go. So that was kind of neat. I can expand that. But now it doesn't look like it's in terms of z anymore. Actually, wait. Oh yeah, it does. I'm just not very good at looking. I like that one better. I still think that looks better, so I'll stick with that. All right, collect. Not entirely sure what collect is going to do on an equation, so let's discover. CLC clear. Sims. I'm never going to spell that right. All right, so say I've got my equation is equal to that, the double equals. And I'm going to collect equation 1, I'm going to collect the y's. Well, that's weird. Well, no, actually that makes sense. Let me collect the x's. Okay, let me collect the z's. Okay, so what if I make it a little different? What if I say z y plus x? What if I collect the x's? Okay, it's just going to collect them per side, it looks like. So if I do an x plus 2 squared here, plus x plus c, I'll just do it on both sides. So it looks like what it's going to do is it's going to collect the x's on both sides, just so that you could do, so this would actually be useful if you ever get to the point in math when you're doing like a coefficient comparison, because that's going to come up. I think you do it sometimes whenever you are doing partial fraction decomposition. Not that this isn't probably totally capable of doing partial fraction decomposition, but a lot of times what you'll do is you'll equate the coefficient of the x squared and equate the coefficient of the x and equate the coefficient of the constant. So this would be a way of collecting the x squareds and the x's and the constants, so I could say, oh, well that must mean that 5 is equal to 2z plus 6, or since this is a 1 must equal 2. Well, that doesn't work because, you know, math, but collect would be a way if you're going to try to equate coefficients on two sides of an equation. I totally see how that would be useful. All right, so we did that. Simplify we've already kind of talked about. Simple, let's do simple. I think simple is kind of fun. I forgot what it did, but I remember seeing it a minute ago and being like, this is amazing, we have to talk about this. CLC clear, sims, x, y, z, simple. Let's just Google it. If I Google it, I will do. Okay. Searches for the simplest form of an expression. Oh, that's amazing. That's very nice of it. So let's try something silly. So y is equal to x plus 3 cubed plus 2 x plus 3 plus 3 plus 3 times x cubed. I don't know. I don't know what I'm doing. Simple. Ooh. How can you not love that? Look, 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 it just did a whole bunch of stuff. I don't know why, but it did. Undock for my minute. Come here, command window. Whoa! Okay. Aw, future, that's sad. Okay. But this is amazing because look, it's like a whole bunch of different ways to simplify it. I don't really know why I would put a combined sin cost line factor thing is. So factor, that was kind of cool. Expand, combine. Anyway, so which one does it like? So basically what it does is it does all these different ones, and then at the bottom, it's like, here you go, I like this one the best. And you're like, hey, thanks, that was great. Anyway, that was kind of fun. Too bad they're going to take it out of a future release. But anyway, simple. Let's just do this again right quick with an equation. And the equation will be fun because we'll do something on both sides. I don't know what I'm doing. Oh, there we go. So what that one did is it put all of the, so this is the first one that we've seen that's going to move things from one side of the equation to the other. So on the left I had a y plus 3, x squared, 3x plus 9, and all of that went to the other side. So I wonder if it would just, because it said to use simplify instead, gave me the same answer, but simple is just kind of cool because it's showing me all the different answers. So I'm not really sure. I'm not sure there's a reason why they're getting rid of it, but that's just, it's something that's kind of cool to look at. Now something I do want to mention is that, like an knows, because we use something called factor, right? So when I had, I don't know, whatever, this thing, and I had, okay, okay, we had something called factor, and it factored it out, or expanded it, or whatever. Well, factor, I guess, could do. Let me give you something that's obvious to factor. X cubed plus 3x squared plus 3x plus 1. And we factored it. Okay, we're like factor. But you might say, but didn't factor used to do something else? And the answer is yes. So if you might remember that if we had factor of like the number 23, not 23, how about 27? it factored it and it said it has 3 factors and they're 3, 3, and 3. And if we factored, you know, I can't think of anything that's not like a perfect something. How about 24? 2, 2, 2, and 3. And it has a different factor. Basically what these are called are overloaded functions, which means that if I'm just doing something normal, factor does what you expect it to do. But if it's doing something with symbols, then factor is doing something super, super crazy. And so that's always something you want to kind of keep an eye out for. If you go help factor, it'll actually show you that it has an overloaded method in the symbol. And that means that factor does different things in different contexts. So that's definitely something you want to keep in mind.